All right, here's a nice log question, and it deals with the laws of logarithms. And so there's a product law. So if you have log of a times b, that's the same as log of a plus the log of b. We have a quotient rule, same game. So if you're dividing two things and taking the log of that, you can say, well, it's log of a minus the log of b. There's a power law that says if you have log of a to the b, you can bring that b out front, and so call it b times log a. So we'll try and use some of those rules to help us simplify this. First problem that we have is that the thing's under a square root. So we need to change the square root to a fractional exponent. So let me show you how to do that. So it'd be log base c of x to the fifth over y cubed z to the fourth, all to the, and if you think of this all being to some exponent here, there's no exponent written, so do you assume it to be a 1. So this would be all to the 1/3. Now this is a power rule for exponents, where if I have something, like if I have x squared to the third, I can multiply that. That's power of a power, so that'd be x to the sixth. So I can do the same thing with this. So this would be log base c of x to the fifth times a third, which would be 5/3, over, on the bottom I have y to the third times a third. What would that be? Let me write it over here. Y to the third to the third. Well, if you multiply those, that'll just come up to 1, so it'll just be a y. And then z to the fourth times a third would be z to the 4/3. Okay, so I applied this 1/3 to that exponent, and that exponent. Okay, now I think I'm ready to do my rules over here, my product and quotient rules. So I can rewrite this then as log base c of x to the 5/3. Since this is divide, now I'll go minus log base c of those things. Y to the first, z to the 4/3. Now, one issue that I have, I can keep simplifying this, but I'm just a touch worried about these ones on the bottom. Because this is times, that means it's a product rule between those two. So let me just break it down a little bit. So it's log base c of x to the 5/3 minus, and then I'm going to expand this with that log rule that was up there. So it'd be log base c of y plus log base c of z to the 4/3. Now, you see that I put brackets in there because this minus applies to everything that's after it, right here, right? So you have to be careful because that's a dirty negative. So I'm going to have to, this negative will apply to this term and to this term. So if I rewrite it out one, maybe not last time, but second last time, log base c of x to the 5/3 minus log base c of y minus log base c of z to the 4/3. Okay, hope things aren't hurting too bad. So this first step that I did, from here to here, that was the quotient rule. I was dividing, and it changed it into a minus. Okay, and then this one here, that was the product rule that got me to there. And then that's just the distributive property that applies that negative sign. And now we use the power rule. And the power rule takes this exponent that's in front of just a base log and brings it out to the front. So I can write this as 5/3 log base c of x minus log base c of y minus 4/3 log base c of z. Okay, hopefully I explained those rules out for you. There's certainly probably ways you can skip over some steps, but to me this just helps sort of make clear in my mind, making sure that I'm using a certain rule to go from one step to another.